Again, for the next problem, we will start by moving everything to the left-hand side and simplify it. Okay, simplify the numerator. Okay, so now that we have simplified the left-hand side, we go ahead and solve this equation. So note that here, this equation only defines when x is not negative 3 and when x is not 2. This equation equal to 0 when negative 2x minus 1 equal to 0, minus 2x equal 1, x equal to a half. Now I will create a table of value and choose the interval. I will create the interval and choose the test value. So the interval that we're looking at is from negative infinity to negative 3, from negative 3 to negative a half, and from negative a half to 2, last one, to infinity. Okay, and the factor that we are looking at are negative 2x minus 1, x plus 3, and x minus 2. And the result here that we want is to less than 0. This is what we want, the interval in which this less than 0. In the first interval, let's choose x equal negative 4. When x equal to negative 4, negative 2 times negative 4 is positive 8 minus 1. That makes this interval be positive. This interval being negative is negative. So hence this interval resulting to be positive. The next factor, let's choose x equal negative 2. This is positive. positive, negative. So then this interval being negative. The next one, let's choose x equal to 0. So here we get negative, positive, negative would make this interval being positive. And in the next case, let's choose x equal 3. X equal 3, then we have a negative, positive, a positive would make this is negative. So therefore, the solution for this inequality is in the interval notation is from negative 3 to negative a half, union with 2 to infinity. And let's take a look at the graph. So negative 3, negative a half, 2, and since this is less than, not equal to, so we have an open interval from negative 3 to negative a half and from 2 to infinity. Last problem. Again, we will move everything to one side of the equation. Simplify the left-hand side. Okay, so now we will solve this equation. Okay. So this equation defines when x is not 0 and when x is not negative 1. This equation equal to 0 when x squared plus x minus 2 equal to 0. And we factor this to get x plus 2 times x minus 1 equal to 0. So x equal negative 2 and x equal 1. So let's go ahead and make our interval and choose the test value. And the equation we want to look at is this equation, and the resulting equation is this one, that we want it to be less than or equal to 0. Okay. And here's our number line. Negative infinity to negative 2, negative 2 to 1, negative 1 to 0 to 1 and infinity. and the factor that we are consider is x squared plus x minus 2, x and x plus 1. So in the first interval, let's choose x equal negative 3, x equal negative 1.5, x equal negative 0.5, x equal 0.5, and x equal 2 for the interval respectively. Okay. When x is equal to negative 3, the first interval in the first factor, we have x equal positive here, negative and negative here. So the result here is positive. When x equal to negative a half, we have negative here, positive here, and a positive here. So the result in here is negative. When x equal to negative 0.5, we have negative here, positive here, and we have negative here. That make it positive. When x equals 0.5, we're positive, 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 hence positive, 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 hence positive. This meant that our interval is in between negative 2 to negative 1. Now, note that because our inequality have a less than or equal, we will include the endpoint. We include this endpoint. This equation is undefined at negative 1. That's why we not including negative 1. Okay? It's undefined at negative 1, so we not include negative 1. So then, the interval notation would be from negative 2 to negative 1, include one end and not the other. And the graph of the solution set is from negative 2 to negative 1. Again, close dot here and open dot here.